Hi, I'm Phil, and today we're going to talk about a robot called Maqueen Plus. And I'm going to get it to climb some ramps and how I do this. So let's have a look at the demonstration, and this will be followed with a video. So I'm going to share the screen. And you should now be able to see the presentation for today. So this block diagram shows the overall hardware that I'm using and what I'm trying to achieve. On the left, there's a Maqueen Plus robot, and it comes from the Chinese company called DFRobot, and they're located in Shanghai in China. And this robot is controlled by a microbit computer. On the project that I'll look at today, I'm also connecting an OLED screen to the I2C port on the Maqueen Plus robot. On the right, there's a BitPlayer, and it can remotely control Maqueen Plus. In addition to being able to remotely control it, I'm getting as much data as I can from Maqueen Plus, including the speed of the motors, the acceleration, the status, and that'll all be transmitted by microbit radio. The BitPlayer can also turn on or turn off the PID algorithm for speed control. So what I'm doing is exploring Maqueen Plus, and I'm just starting off at the moment, but later I'm going to extend the projects to include the Huskylens AI vision and see how that can be used for robotics control. So today I'm only really going to focus on my experiences on some of the early projects, particularly in commissioning, to see if this robot works or not. And I'll include a critique of some of my experiences so far, together with references. So just a little bit about the Maqueen Plus robot. I bought a package that included both Maqueen Plus and Huskylens. And so far I've tested them separately. I've done lots of unit tests, but I haven't actually put the Maqueen Plus and the Huskylens together yet. So I'm looking forward to doing that. So Maqueen Plus is quite suitable for STEM education, particularly in the middle years. So I'm going to use it for after-school projects with the Blacktown Council, Mount Druitt Library STEM Club, and we'll be able to learn a bit about robotics in that club. So some of the good things about it is that it's got excellent line tracking. So it's on many robots, you only get 2 line sensors, but on this one you get 6, and there's a lot you can do with that for finer control. You get an excellent battery. The 18650 battery lasts me all day, although it does take a while to charge. So just keep a spare one, or if you have a handy battery charger, although it's a little bit difficult to fit the battery on the battery holder on Maqueen Plus. I got Maqueen Plus at a discount price, and it only arrived a couple of weeks ago, and I've done many projects with it already. So I'm going to talk about the ports that are available, the motors. So it also has a couple of LEDs on the front, and plenty of LEDs also for diagnostics. There's a buzzer and a infrared receiver although you don't get a infrared transmitter with the package. You have to buy that separately. An ultrasonic sensor is included, but I've had a bit of difficulty with that because in some ways the Maqueen Plus is not open sourced. So you're not quite sure how to do your own programming if you don't have the ultrasonics handheld controller from DFRobot. So I put in my own ultrasonic sensor in there and some power options. We've spoken a little bit about that already. So ports, you can add 3 servo ports. There's expansion for the I2C ports, and on the project that I'm talking about today, I'm going to use an OLED screen to show the results of the robot, all the parameters of movement. There are 9 GPIO expansion ports. And you might think, oh, it's great that you've got all this expansion. It looks a bit like it's an open source piece of hardware, but there's a lot that's still hidden. And the infrared receiver is an example of that. You've got good motors. So they're geared, N20 geared motors. They operate at 260 revs per minute and powerful enough to do all the projects that I want to do. In addition to the power, you've also got encoders on the motors and PID control. And again, this is another aspect which is hidden from you. You don't know how the PID algorithm is done. And I suspect that there's another computer on board that does all of that. So the PID is controlling the speed of Maqueen Plus. And the project that I'll be looking at today is utilizing that aspect. Perhaps just a little bit more. We've already spoken about the GPIO ports. All of these ones are available if you want to use them. But there's still plenty you can do, despite the fact that it's not totally open source. It has a lot of potential, particularly in that mid-ground of STEM education. And I focused on a robot that has good blocky or graphical support using a programming language like Microsoft Makecode. And there are good packages available from DFRobot. There's one available for the Maqueen Plus, and it does most of the things you'd like to do. But unless you have the IR transmitter from DFRobot, you can't use the receiver, the IR receiver block. Since I'm adding an OLED display, DFRobot has a OLED display that I can put on the robot, and we'll have a look at that later. And there are some Makecode extension blocks available for that. So my alternative RF receiver, I've got software blocks that covers that. And for the remote control, I'm using from Tinkergen, now part of the SEED organization in China. I'm using BitPlayer, and there are some good Microsoft extension blocks available for that too. So the projects, assembly was my first project, then the commissioning. And for the commissioning, I used the tutorials available from DFRobot called Getting Started with Maqueen Plus. I'm interested in taking it a bit further. And the first project I'll look at will be calibrating the distance, because you're able to measure the revolutions of the motor, and it should be a simple matter to convert that to a distance once you calibrate it. Then I think the most exciting part will be looking at how I can extend this with the Huskylens. And I should be able to do many projects from line tracking all the way through to identifying road signs and doing some other control with on the Maqueen Plus robot. And finally, I'm going to put some of these together in robotic stories, like road safety is one of them. Another one will be delivering parcels to houses on a special robot mat. And finally, I'll be looking at factory automation and how Maqueen Plus can collect parts and deliver those to assembly points, collect everything, ready for dispatch. So this was an easy project. Assembling Maqueen Plus was not hard at all. It only took me 10 minutes, and I assembled 2 of these. And this is pretty good for a STEM club or an after-school group in STEM education, where you've got very limited time. And if you've only got an hour per session, for some robots, even for the very cheap ones, like BitPlayer, it would take an hour. So being able to involve STEM students in the assembly process, but not making that take up all the time, is quite an advantage. So in the commissioning, I went through all the chapters in the Getting Started tutorial, and all of these involve small tests, and they're really projects on their own. So I've done all of these. They all work. They're quite good, and they all offer extensions and suggestions where students can take some of the ideas a bit further. And some of them, like the line or the crossroads on chapter 10, I've never actually done that before, and that was quite interesting. It gives me another insight into robotics. For the rest of this presentation, I'm going to concentrate on that tutorial, particularly on chapters 12 to 14, where I'm going to combine a few concepts in the one package. So I'm going to look at how I can get my Maqueen Plus up a ramp without stalling the motors. I'm going to transmit all the parameters of the robot, the speed, the direction, the acceleration, all by radio. And I'm not only going to do it on radio, I'm going to also show on the OLED screen, which is on the robot. And here's the OLED screen. The first thing you can see on the top line is that I'm giving each of the robots a registration number. So Maqueen 1, it's telling me that the PID is off. It's, at the moment, it's stationary. So the left motor speed and the right motor speed is 0. The direction is 0, which means it's stationary. It's also telling me the number of revolutions it's done on each motor and the overall acceleration. So let's explore the rest of the project. First of all, I'll tell you what the objectives are. I'll go into detail on the hardware, a little bit on the design, but I'll concentrate more on the communications protocol. And on the software, I'll just go over some of the key points on the construction there. And for the results, I'll show you a video. And I'll talk about some of the issues and give you some references. So my objective here was to try and emulate some of the things you might do in real life. So each car has a registration number, and that's what I'm doing. I'm giving not only a registration number to each robot, but I'm also going to identify what the unique microbit serial number is and transmit that as well. So we can easily identify the robot, and we can have a number of these robots, and we are able to track and know the parameters of each. So on each robot, I want to set the direction, either forward, reverse, go left or right. And I can do this in a couple of ways. One way is to use the microbit buttons, button A and B. And I've got plenty of ways for stopping the robot, particularly in an emergency. I'm going to transmit the robot ID, the acceleration, the speed, the robot direction, and the motor revolutions. So on BitPlayer, I want to decode all of those. And they'll be then relayed or routed to my Windows PC. And I'll use a serial terminal to do that. Microbit can also remotely control the speed and direction of the robot. It can stop the robot, and it can activate by switching on or switching off the PID speed control. So to do all of that, I need to develop a communications protocol. So on the OLED screen, I want to show the vehicle registration number, the state of the PID algorithm, whether it's on or off. I want to show the speed of the left and the right motor, the direction that the robot is taking, how many revolutions there has been on the robot, and the acceleration. So for my hardware, I'm using the Maqueen Plus robot. And I've added to that a gravity module, which also comes from DFRobot. It's a I2C OLED screen. Quite a nice screen. It allows me to show up to 8 lines of about 40 characters per line. And I've got 2 microbits, one on Maqueen Plus and the other one is on BitPlayer. So for my design, I've got a communications protocol, and this transmits everything I want to know about Maqueen Plus and its movements to BitPlayer, so that BitPlayer remotely knows what Maqueen is up to. So the packets include an ID packet. And in fact, on all of the other packets, I'm also transmitting the registration number of the robot. So the other packets are the acceleration, speed, and the number of revolutions. And this allows me to do and explore a bit of navigation on the robot, just using speed, acceleration, and transferring that into a calibrated distance. For software, I'm using Makecode. And for the extension, it's readily available on the internet. And I'm going to use Makecode for both the control of Maqueen and also for BitPlayer. I won't go into full details, but this is the overall control of Maqueen Plus. And while these are in blocks of each column does something special. So on the left, we start up. The next row is a forever loop, and it's really just going round, finding out if there's another command to perform on the robot. And those commands can be done either via radio, so there's a radio receive block, or I'm processing events from the button or from the logo. So I'm using microbit version 2, which allows me to use the logo as another input. And the rest are really just functions. The first block in the middle there is about turning on or turning off the PID algorithm. The next one is getting the speed parameters, not only speed, but direction. And on the final column on the right, I get the ID of the vehicle. I find how many revolutions, and also get the acceleration. So if you explore these in detail, the startup is showing the name of the program and setting the microbit radio group to 1. So both BitPlayer and Maqueen have to be on the same radio group. I'm initializing the OLED display and getting the device serial number from, now that's embedded within microbit. It's a bit like a vehicle identification number. And I give each robot a vehicle registration number. And the next part is establishing a command array of all the remote messages. So if I want to do something like move north, south, east, or west, then I can use English commands, and these are derived from the radio or the events on pressing the buttons. So in the forever loop, I'm really just scanning to see what the current action is. And after I found that action, I then call other functions like get the ID and transmit it, then get the speed, the acceleration, and the number of revolutions. So here's an example of the event button. So when I press button A, I want to go north, which is really just going forward. If I want to go reverse, I'm going south, and that's button B does that. So to turn on or off the PID algorithm, I just press the logo. And this is what happens in that function for switching off the logo. I set the flag, switch off the algorithm, and switch the motors onto a speed of 30. I show a Q on the microbit LED array, and I also show the status of that on the OLED display. Similarly for the PID on. So here's a short example of how I'm getting the left speed measurements, and I convert these parameters into a string, and I'm joining these together, bearing in mind that microbit has a limitation of 18 characters per packet, but I'm joining the speed ones together, and I always put together an identification of what the packet is, what the vehicle registration number is, and then the parameters. So here's the example for acceleration. And I get the acceleration in the X, Y, and Z direction. And then these are all combined into strength. And in the combined packet, I'm adding the vehicle registration number together with only the strength, although I could extend this for each of the dimensions of X, Y, and Z acceleration. Now on BitPlayer, I need to decode all that, but also process events that happen if I press the buttons on BitPlayer. So I've got keys and I've got a joystick. And the keys allow me to do event programming. So if I press button A, B, C, or D, I then direct Maqueen Plus in a certain direction. If I want to turn on the PID algorithm, I press the left button, and the right button turns off the PID algorithm. Okay, I'm going to show the results later on using a video, but overall, I was quite pleased with the results. And if you remotely switch off the PID algorithm, Maqueen Plus has quite a struggle to get up that ramp. In fact, just stalls. And if you switch on the PID algorithm, it maintains a constant 30 reps per second, and it can easily climb the ramp without a problem. So some of the issues, there was a significant latency between BitPlayer as a remote controller for Maqueen Plus. So you couldn't really use this in a active scenario. Good enough for what I want to do on this project, but I'll have to look for faster ways of communicating, particularly in an emergency stop. I also noticed when I switched on the PID, the speed actually changes. And this really shouldn't happen. The PID should maintain a constant speed. That's interesting. And also, you can't use the PID all the time. If you want to really get the robot moving, some of the times you might have to switch it off, because there's even an internal latency within the algorithm. So overall, I'm quite happy with the DFRobot Maqueen Plus, and I'm looking forward to extending that with the Huskylens AI vision sensor. So it's a good platform for mounting accessories. For example, on the BitCar robot, it's really hard. It's hard to, even though that there's some Grove ports there, you can't really mount them without causing a problem to the robot. You've got good access to GPIO ports. There's about 9 of them available, so you can add plenty of other things if you want to. There's support for Huskylens, not only in hardware and the interface, but also there's plenty of tutorials available on what you can do with AI vision in robotics. It's really easy to assemble. And there's good Makecode blocks available for it. There's also the motor encoders, and there's an embedded PID algorithm. Although you don't know what's going on internally, all of that's hidden from you. You've got access to additional servos if you want to add them, and there are 3 of those available. On the downside, and I think this really depends if you've already got a platform. So I've got 2 platforms. One is MakeBlock, and I've also got the seed robots, and they use Grove modules for the sensors and actuators. And the Maqueen Plus and the platform, it's just not compatible with all of that. Although it's quite possible to use the Grove modules with a special cable that allows you to still plug those into the sockets on the Maqueen Plus. The remote control kit is not supplied, and it really should be. So I've discovered that you can get a remote control as part of a separate package. There's no schematics available, so it's not really totally open source. And there's no alternative IDE available, although there is some support for MicroPython. So if you want to get the STEM students away just from a blocky language and go to a script language, at least you can follow MicroPython. There's no Arduino IDE support, and I think this is a bit of a problem. So you really need to have very strict version control. That is, know what version of Makecode you're using, download for your own protection the extensions, and if you want to come back 6 months later, you can come back to the same version configuration. So I found that the Grove connections are much better than the headers that are supplied on Maqueen Plus. And sometimes those headers, particularly if you have quite a lot of them connected, can easily fall off. And it's actually quite tall. So on some scenarios, like on the robot mats, it's not really compatible with those. Okay, here are some of my references. The project and all of my commissioning was based on checking out the Maqueen Plus Getting Started tutorial. And I found that quite useful. And you could use that as the basis of a robotic course in STEM education. I've also have a reference for the BitPlayer and the OLED screen. So the references from DFRobot are available, and these allow you to get access to all those chapters and additional chapters if you want to add the AI vision. And for BitPlayer, you can get resources available from Seed and from Tinkergen. Okay, so we'll now look at the video.
This is the Maqueen Robot Plus on the left, and on the right we've got BitPlayer, which is a remote controller for Maqueen Plus. Looking at the configuration, both are driven by microbit computers, and there's an additional OLED display that's added to Maqueen Plus. Now, what's interesting about this is that all the parameters for motion, the top line shows the identification of the robot and whether the PID is on or off. It shows the speed, the measured speed on the right motor and on the left motor, the direction of travel of the right and left, and also the number of revolutions. And the last one is the acceleration. So all of that is not only displayed on the LCD of the robot, but it's also transmitted to BitPlayer remotely. And BitPlayer, if it connects to its serial port, it can collect all that information. Now, what we're doing here as a demonstration, we're also going to remotely turn on and turn off the PID algorithm that sets a constant speed. So let's have a look at that. We're going to put the robot on the track, and at the moment the PID algorithm is off, and let's see if it can go up the hill. So on the remote, we'll just press the forward button, and you can see the robot has stalled. We'll just reverse it. And we'll stop it. Okay, so what we're going to do now is put the PID algorithm on. So we just press the left button, and the PID algorithm is now on, and the robot is now going a little bit slower, but we'll just see how it negotiates that hill. There you are, and there's Maqueen with the PID algorithm switched on. The only problem we've got is there's a bit of latency in the transmission from BitPlayer to Maqueen Plus.